Hello, in this video I will show SprutCam possibilities for the continuous 5-axis milling. So if you have SprutCam with the SprutCam configuration with module works operation, then this page, this operation must be available on your SprutCam. Exists SprutCam configuration without this operation, then it is disabled. So the machining page, creating 5-axis. All this is module works operation. So module works is external kernel in SprutCam. It is developed and the manual for this kernel you can find in the main menu, all programs, Sprut Technology, SprutCam 7, Module Works Manual. I open it. It is huge manual. It contains a lot of topics, and when you use and I recommend to read it to understand the all possibilities of module works operation in SprutCam. It is not possible to show all possibilities in a small presentation. Well, so if you have the configuration with SprutCam configuration with module works, and also if you have a look on the manual, after that I recommend you to research the example project that included in SprutCam. So there to find it, click open project, and libraries, documents, SprutCam, SprutCam version 7, projects, examples. After that, here we can find 5D milling. Open it, and for example, this project and another project, there are the projects with module works operation. For example, let's open this blade point SDC project. Okay, in this example we use VI冶T 800 machine. This machine, first two operation, it is SprutCam operation roughing waterline from one side and from another side, and the last three operation, it's the module works operation. Let's look on it in simulation, and after that we can research how it is done. Well, make toolpath invisible. One moment. Also for 5-axis milling, I always recommend to use a simulation method, voxel 5D, and this parameter is used to calculate the workpiece between operation. And there is another switch of simulation. I recommend to select voxel 5D also. It is on the simulation page. Well, let's now start the simulation. What's wrong with it? Okay, speed too slow. Well, this is simple roughing waterline for the first, and the next operation is rotation, after rotation. Well, so after the first indexing machining, we have this workpiece. Make the tool invisible. So The next operation is 5-axis multi-surface operation. It is a module works operation, 5-axis multi-surface, multi-surface. Okay. Well, it generates the toolpath like this one. It generates something like this, and this is the toolpath. If I make the machine invisible, okay, let's have a look on the parameters of this operation to understand how it was defined. Go back to machining, make machine invisible. It is not interesting for us here, and then click parameters. Okay, all module works operation have the same tool page like in another operation in SportCam. Federate page is the same, toolpath template the same. So the surface path, this is module works page. So we can see that for the current operation, set the calculation based on the surfaces. It is possible to use triangle mesh or swarf machining. The pattern is morphed between two curves. To define the curves, I click first, and we can see highlighted first curve. The edges from the model is selected as the first curve. Click cancel. Second, we can find that the second curves list is also defined here. So our operation generates the toolpath from this curve to this one. Also the next, drive surfaces. Click drive surfaces, and also we can select some surfaces here. I click cancel, drive surfaces again. Okay, so in my operation defined this morph curve, this, and this is drive surfaces. Click parameters again. So the tolerance end step is here. Well, this surface path define the law how the curves going along the surfaces. The next page, tool axis control. Tool axis control. On this page it is possible to define the way how the tool axis will be changed. Well, there are three ways: 3 axis, 4 axis, 5 axis. We have 5 axis, and a maximum angle step is defined for the, and tool axis will be tilted relative to the cutting direction. So it means that the tool axis depends on the machined surface cutting direction. Well, and there are two parameters: lead angle and tilt angle. Well, right now it is 0, and so we have the toolpath like this one. So the surface is, there is a go and going back. Okay, let's say we'll change, for example, lead angle and set 30 degrees. It is possible to define positive or negative angle here. set it and recalculate. Well, not all path is calculated, but let's have a look on the result. So right now we can see that the tool is inclined on 30 degrees, and so on. Well, what is the... I set lead angle to the 0 again and set tilt angle the same 30 degrees. It is incline of the tool, and recalculate the tool path. Well, let's have a look. So right now the tool is inclined along the axis. Okay, so the tool axis control page define the law how the tool axis will be located. Go back, set to the 0, and the next page is the gauge check. Gauge check define the checking, part checking for the tool. So we can disable the checking anyway. Then it is possible that tool will cut the part. For example, I can enable the tool checking, enable this part of the tool, what I would like to check, what I would like to do if collision is detected. For example, if we have some collision, then we will retract tool along the tool axis. It is possible to incline tool away. It is possible to report collision and so on. And also in this step it is defined what surfaces will be checked, and all surfaces is added to the list. So to define the surfaces for check, click this button and select it from the face. So I can define, for example, another checking. So if the holder is checked, is collision with the holder and with this part, then I would like, for example, to tilt the tool and define the same surfaces. Okay. And parameters: max tilt angle, for example, 45 degrees. Okay. So it is possible to define different checking laws. Let's play with it. Try to recalculate. I think it will not have a matter with my example. Okay. Well, the next is the links, clearance area, and gauge checking. I will disable it and go back to the links. The way how the toolpath is connected. For example, I can say that the clearance area is the cylinder with the radius 200 millimeters. Cylinder is parallel to y-axis. Okay, so, and a lot of parameters to define the lead-ins and lead-outs. Well, the next page is roughing. Right now in this example, the toolpath is generated without roughing, but I can, for example, enable multi-passes and roughing passes, for example, set free layer and spacing, for example, 3 millimeters, and the sorting method. Okay, enable multi-passes, okay, and recalculate the toolpath. Toolpath calculation needs some time. Well, let's have a look. So right now we have three cuts for the roughing. So if I disable it, then we will have, and there is a lot of another roughing methods. And the last, feed ray control, axial shift, and different parameters. So that's only quick tour along the module works operation, and I recommend you to play with it and read the manual. So thank you for your attention. Bye.